Good morning. Today's video we're going to discuss about what is the compiler design, what is the introduction about the compiler design, what are the different tools we are using it, what are the different major tasks like analysis and synthesis phase in this compiler design. So the main objective of compiler design that is a simplified language. The compiler constructions tools we're going to discuss and what is the different visual machines and LL of 1, LL of R0, LALR of 1 and what are the compiler analysis, what is synthesis, what are the different phases of compiler and optimization technique and main idea behind this is we're going to discuss what is happening in the back end of the systems, that is back end of computer, what is the process is going on, how the machine is acting for the source code. So now the compiler is a computer program that transforms the source code into a target level language code. The target level language code is in the sense machine level language. That the binary forms is known as a object code. That object code is a executable program. So here it's a compiler. The compiler will convert the source level language, that is high level language, into a machine level language code. So the machine level language code is ones and zeros. The main idea is about what is compiler, what is interpreter difference. That compiler and interpreter in that compilation. What is compilation is nothing but the translation of program written in a source level language into a semantically equivalent program written in a target level language. So the source program we are converting given to the compiler as a input. That source program input is the high level language, maybe Java, C, C++, Python. If any error occurs, it will show the error message in the compiler. If there is no error, it will compile the source level language program into a machine level language, that is a target program. And then interpretation is nothing but the source program is given as to the interpreter as a input that performs the operation implied in the source program. What are the operation is given in the source program, it will be performed, that is performing the operations in the interpreter, and the output is a equivalent machine level language. Analysis and synthesis, there is a two parts of compilation. One is in the analysis, determines the operation implied by the source program which are recorded in a tree structure, that is analysis phase. Synthesis is nothing but the tree structure and the translates the operation therein into the target program, that is a synthesis task. There are different types of tools available that is used for the analysis synthesis model. The first one is editor, syntax highlighting, pretty printer, doxygen, and static checker, that is a splint, interpreter, text formatter, that is lantex, silicon compiler, that is VHDL, very high definition language, and query interpreter, that is a database. There is a, if you give the GCC command in the compilation, what is happening in the system? First, the source program is given into a preprocessor. The preprocessor gets the source program. Then the source program is given into a compiler. The compiler translates the source program into a target assembly program. And then that assembly code program is given to the assembler. The assembler will get the output as a relocatable object code. The relocatable object code is again given to the linker. The linker will get the absolute machine code. The linker, what it will do is it will connect to the libraries and relocatable object files. That has happened in the compilation GCC. The main, the first compiler is designed as Photon in 1915s. 18 persons worked to design that compiler. It takes year to build. There is a structure of compiler, that is analysis and synthesis, two phases. That is, first phase is called as front end, second one is back end. In the front end analysis, the source program is converted into an intermediate code representation. That intermediate code generator is given to the synthesis phase, that is a back end. That intermediate code representation is converted in the synthesis phase into equivalent machine code. That is happened in the synthesis back end phase. So analysis the source program, synthesis the machine level language program. So now whatever the content what we discussed in this video is what is compiler, what is interpretation, what are the different tasks like analysis phase and synthesis phase, what is front end, what is back end, what is the source code, what is a machine language code, and we discuss if GCC, if you press, what is happening is preprocessor, compiler, assembler, linker. How the flow was, the source program is given to preprocessor, the process converts that into source program. Again, source program given to compiler. Compiler translate into assembly level language program. And the assembly level language program is given to assembler. Assembler will convert it into a relocatable object code. The object code is given to the linker. The linker will do the linking operation like it link library and reload the object files. The linker output is absolute machine level language program. So now we know what is compiler. What are the two phase task of major task of compiler? That is analysis and synthesis phase. Correct. In the analysis phase, the source code is converted into ICG, that is an intermediate code generation, and that code is given in the synthesis, that is a backend. That program is converted into a mission level language code in ones and zeros. I hope you understand what is compilation now. We'll see in the next video. Thank you.